So guys, welcome to our channel once again. In today's video on our physics WAEC exam revision series, we have here these 4 WAEC repeated questions to answer on the topic electric fields. So guys, this video will be about potential difference and electric currents. So in short, stay till the end of this video. Let's go ahead and start with the first question here. It says, a voltmeter is a device that A. draws high current, B. has a high resistance, C. is able to measure both voltage and current, D. has a very high resistance. So guys, actually a voltmeter has a very high resistance, and as such, option D is the answer to this question. So you see the rest of the options. The voltmeter does not measure both voltage and current, neither does it have a low resistance, and it does not draw high current. So the only option that suits the answer to this question is option D. So let's go ahead and consider the next question, guys. That's question number 2 here. It says, what is the potential difference between X and Y in the diagram below if the battery is of negligible internal resistance? So guys, for this diagram here, to find the potential difference across X and Y, we have to first of all find the sum of the resistance in this parallel connection in X and Y here, since V is equal to IR. So when we find the resistance here, then we can now get to the total resistance from the entire cell, and then from there we can now find the current, and if we are able to get what the current is here, then we can now use V is equal to IR again to find the potential difference across X and Y. So let's go ahead and do that together. First of all, to find the resistance from X to Y, we can simply do 3 times 2 over 3 plus 2. So when we do this, that will give us 6 over 5. So in that case, R for X and Y will be 6 over 5. So now that we've gotten this as 6 over 5, we're going to add it to this 0.8 ohms in series. So resistance in series, R total for resistance in series will be 6 over 5 plus 0.8. Actually 0.8 is 4 over 5. So let's say 6 over 5 plus 4 over 5 will give us 10 over 5, and 10 over 5 is equal to 2. So now we've gotten the total resistance to be 2. We can now find the current using V is equal to IR. So when we do this, we have that I is equal to V over R, where the V is 5 and R is 2. So 5 over 2 will give us 2.5. So in that case, I is 2.5. So now that we've gotten the current across the system here, we can now simply go ahead and look for the potential difference across X and Y. So V here across X and Y will be I, which is the current, times the resistance R across X and Y. So we initially calculated the resistance across X and Y to be 6 over 5, and we actually got the current in this system to be 5 over 2. So in that case, we can multiply 5 over 2 by 6 over 5, and we can cancel out 5, and then we have 6 over 2, which is 3. So guys, the potential difference across X and Y here is 3 volts, and that's option B here. So let's go ahead and consider the next question, guys. So that's question number 3 here. It says, using the circuit diagram above, calculate the potential difference across the capacitors in parallel. We have A, 8.0 volts, B, 2.0 volts, C, 6.7 volts, and D, 10.0 volts. So guys, we are told to calculate the potential difference across the capacitors in parallel here. So let's recall the formula that Q is equal to CV. So if Q is equal to CV, it means that V will be Q over C. So in that case, to find the voltage across these 2 microfarad capacitor in series here, we divide the 16 microcoulombs by 2 microfarads. We are going to have 8 here. So if we have 8 volts running across here, it means that the potential difference that will be across the capacitors in parallel will be the total potential difference minus the 8 volts potential difference you have here. So that will give us 10 volts minus 8 volts, and that's 2 volts. So option B is the answer to this question, guys. Let's go ahead and consider the next question. So guys, the next and last question we have here is question number 4 here. It says, using the data on the diagram below, calculate the potential difference across the 20 ohms resistor. So guys, looking at this here, we have this setup, and we can see current flowing from the 5 ohm resistors here, and then the 10 ohm resistor here, and then the sum of this current will flow down to the 20 ohm resistor. And let's go ahead and check this out. Now, for us to calculate the potential difference across the 20 ohm resistor, first of all, we'll calculate the potential difference across the 5 ohm resistor using V is equal to IR. So here, the V1, which is the voltage across the 5 ohm resistor here, will be 2, which is the current, times 5, which is the resistance, and that's 10. So V1 is 10 volts. But let's take note that this 10 volts is also moving across the 10 ohm resistor. So in order to get the current also moving across the 10 ohm resistor, we are still going to use V is equal to IR, and then we'll make I the subject of this equation, where I now becomes V over R. V, which is 10 volts over the 10 ohms here, will give us 10 over 10, which is 1. So in that case, we have 2 amps flowing from this 5 ohm resistor, and then we have 1 amp flowing from this 10 ohm resistor. So in that case, the current that will get to the 20 ohm resistor is 3 amps. So if 3 amps is the current getting to the 20 ohm resistor, we can now calculate V2, that's the voltage across the 20 ohm resistor. So that will be V2 is equal to IR, that's the I2 times the R2. So in this case, the V2 will now be current, which is 3 amps, times the resistance, which is 20 ohms. So 3 times 20, guys, is 60 volts, and that's the answer to this question, option D here. So guys, this is where we'll end this video for today. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not a subscriber. Also, if you have any specific question regarding this video, you can drop your question in the comment section, and we're sure to give you a response. So finally, guys, we want to encourage you to join our YouTube channel community, where we post major updates on WAEC examination. This will help you a lot even as you prepare for your WAEC examination for the year. So you can join this channel community by hitting the join button below, and we'll see you right there. Thank you once again for watching this video, and see you on the next one.